Welcome, listeners, to HP News Channel, where we together explore the mysteries of the vast universe. Today, we delve into a groundbreaking piece of news, a discovery with the potential to completely alter humanity's perception of its place in the cosmos. Scientists have just announced the strongest evidence yet for the existence of life on a distant planet. Could this be the historic breakthrough we've long awaited? Or just a faint glimmer of hope amidst the countless unknowns out there? Hundreds of trillions of miles away, or more precisely, 124 light-years, lies a distant world orbiting a red dwarf star. This planet is named K2-18b, and it's about 2.5 times the size of Earth. Over time, K2-18b has garnered particular attention from astronomers due to its promising characteristics for the existence of liquid water, a key ingredient for life as we know it. Recently, a research team at the University of Cambridge announced the latest findings about the atmosphere of K2-18b using data from NASA's James Webb Space Telescope, JWST. JWST, with its superior cosmic observation capabilities, has allowed scientists to analyze the chemical composition of the planet's atmosphere by examining the starlight passing through it. And what they found is truly groundbreaking. The Cambridge research team detected the chemical signatures of at least one of two molecules that, on Earth, are only produced by simple living organisms: dimethyl sulfide, DMS, and dimethyl disulfide, DMDS. DMS, in particular, is a gas released by marine phytoplankton and bacteria on our own planet. The presence of these molecules in the atmosphere of a distant exoplanet has ignited hopes for the existence of life beyond Earth. Professor Niku Madhusudan, the lead researcher at the Institute of Astronomy at the University of Cambridge, couldn't hide his surprise at the amount of gas detected in a single observation. He shared that the estimated amount of DMS in K2-18b's atmosphere is thousands of times higher than the amount of the same gas on Earth. This suggests a thrilling possibility. If the link to life is real, then this planet could be teeming with it. Professor Madhusudan confidently states that this is the strongest evidence yet for the potential for life out there. He even expressed hope that his team could confirm this signal convincingly within the next 1 to 2 years. However, both the research team and independent astronomers agree that more data needs to be collected to solidify these initial findings. The reason for this caution lies in the rigorous standards of science. For a discovery to be recognized, researchers need to achieve a very high level of statistical confidence, typically a 5 sigma level, equivalent to a 99.999999% certainty. The Cambridge team's current results have only reached the 3 sigma level, or 99.7%. While this sounds high, it's still not enough to fully convince the scientific community. Even if the Cambridge research team achieves 5 sigma results, a crucial question remains: the origin of the DMS and DMDS molecules. On Earth, they are produced by microorganisms in the ocean, but Professor Catherine Haymans of the University of Edinburgh and the Astronomer Royal for Scotland, an independent expert, argues that we cannot rule out the possibility that these molecules were created by non-biological, geological, or chemical processes on K2-18b. The Cambridge research team agrees with this viewpoint. They are collaborating with other groups to conduct laboratory experiments to investigate whether DMS and DMDS can be produced through non-living means. Professor Madhusudan acknowledges that there is still a 0.3% chance that this is just a statistical fluke. Another contentious factor is the internal structure of the planet K2-18b. The reason many researchers believe this planet has a vast liquid water ocean is the absence of ammonia gas in its atmosphere. Their theory is that ammonia has been absorbed by a large body of water beneath. However, Professor Oliver Shortall of the University of Cambridge offers an alternative hypothesis. K2-18b might possess a hot, molten rock ocean, an environment completely unsuitable for life as we know it. Dr. Nicholas Wogan at NASA's Ames Research Center has yet another interpretation, suggesting that K2-18b could be a small gas giant with no solid surface. These different hypotheses highlight the complexity of deciphering the faint signals we receive from hundreds of light years away. Professor Chris Lintott, host of the BBC's The Sky at Night, expresses his admiration for Professor Madhusudan's team's work but still urges caution. He believes that we have had similar moments in the search for extraterrestrial life before, and that we should avoid making hasty pronouncements. Nevertheless, Professor Madhusudan remains optimistic. He believes that his team's on the right track and that finding convincing evidence of life on another planet is only a matter of time. He hopes that in the not-too-distant future, we can look back at this moment and realize that it was when a living universe came within our grasp, when the fundamental question of whether we are alone in the cosmos finally had an answer. This discovery, published in the Astrophysical Journal Letters, has opened a promising new chapter in the journey of exploring the universe and seeking answers to one of humanity's greatest questions. Let us await the next results from the James Webb Space Telescope and the tireless efforts of scientists worldwide. And that concludes the story of the promising evidence for life on the planet K2 to 18b. The journey to explore the vast universe is still very long, and discoveries like this ignite within us endless hope and curiosity. Thank you for taking the time to listen to HP News Channel. Please continue to follow us so you don't miss other fascinating scientific information and space explorations.